Hello, this is Mukesh Kushwaha, and in this video, we are going to talk about vector addition and vector. So, as you have already, I think you must have been knowing that vector is a quantity that has direction and magnitudes. So, let's begin with the basic. What is the importance of direction? Suppose you say that 1 kg of sugar. By stating that 1 kg of sugar, you are able to completely state what you mean. 1 kg of sugar means a bucket full of sugar or something like that. And telling 1 kg of sugar, just mentioning the magnitude, completely states what you really want to say. But sometimes it's not enough to just state the magnitude. For example, you have a rotating wheel. And this wheel is rotating with the velocity of 5 rotations per minute. 5 rotations per minute. Stating 5 rotations per minute is not always enough. Stating 5 rotations per minute is not enough. By stating 5 rotations per minute, you are not able to state completely about this. Another component of what we see, it is rotating in clockwise direction or anti-clockwise direction, has to be aided. If you want to really completely state about this rotation, so if you want to measure the rotation, then you have to add two components. One, the velocity with which it is rotating, the speed with which it is rotating, and the direction as well. So this angular rotation or angular velocity, which we call, contains two components. First is velocity, or speed with which it is rotating, and the direction in which it is rotating. In the same way, in physics we have different quantities with which we have to associate our direction, and a direction has to be attached, and such quantities with which interaction as well as magnitude are attached are called vectors. Force, velocity, momentum, torque, couple, angular rotation, all these things are area, are all vectors, quantities. Now let's see how we add vectors. A vector is added. Suppose we take example of, suppose we have a stone here, and this stone is being pulled with a vector with a force of 5 Newton, and the stone is also pulled by another boy with another string in same direction with a magnitude of 3 Newton. So overall the force acting in this direction will be considered to be 5 plus 3 8 Newton. Okay, now this 5 plus 3 8 Newton force is acting on this body of mass 1 kg, suppose. So the acceleration will become force by mass, which will become 8 meter per second. Acceleration will come out to be 8 by 1. Okay, now in the same way we know how to add vectors from this simple example. How? If the vectors are in same direction, we add them up algebraically. If they are not in same direction, they are opposite direction, we subtract them. Suppose this same stone was being pulled in this direction as well as in this direction with magnitude of 5 Newton and with the magnitude of 3 Newton in these two directions, which are exactly opposite to each other. So the overall force will be 5 minus 3 2 Newton in the positive x direction. Overall force will be 5 minus 3 in this direction. Here also the overall result will be in this direction. So the resultant force magnitude will be 8 Newton in the upper case, and this lower case the magnitude will be 2 Newton in the x direction and 8 Newton in the x direction respectively. Now from this basic principles, first of all we need to understand one more thing, that when we represent vector with these arrows, the magnitude of that vector is directly proportional to the length. So suppose a vector whose length is 10, suppose this is a 10 Newton vector, we represent it with a 10 Newton vector. So 20 Newton vector will be exactly double its size. That is what we mean by proportionality of the magnitude. So this is 20 Newton. If the length of this line is exactly double, this is the systematic way of representing vectors. This is the way we represent vectors. So this is 10 Newton. Suppose this is 2 centimeter, so this must be 4 centimeter. In this we represent vector, that is their magnitude is directly proportional to their length when we represent it on papers. And you should also take care of this convention while representing, because in several cases it might not work out if you do not represent with the right length of the vector. Now that we know how to add vectors, simple vectors, we can add some more complicated vectors also from this basic principle, that we know that if two vectors are in same direction, we just add them their magnitude and the resultant direction is also in the same direction. Suppose this is 1 and this is 3. If the upper vector is 1 Newton and lower vector is 2 Newton, so the resultant will be 3 Newton in the same direction. In this same direction, this will be the resultant. Okay, now if this is the case, if this is the principle of adding vectors, so we can add other vectors also with the same relation. We can do any vector, we can resolve. Now before with that, we need to understand one component thing. What component is? So any vector in any given direction can be broken down into two standard directions, three standard direction, x, y and z direction, because adding them in, if a vector is in same direction, then it can be, if the vectors are in same direction, they can be added easily, as we have seen before. So if these are two vectors, suppose they are not in same direction, how will you add them up? So there is a very easy method which we call component method for doing this. First of all, what we do is break these vectors, these two vectors in their x and y components. So we need to understand what component is first of all. So let's understand what component is. So if this is a vector and this is your standard xy coordinate system, this is your Cartesian coordinate, this direction is x and this direction is y, then you can break this vector into x and y component. What you mean by that is, this vector is made up of these two vectors by parallel law. This vector is made up of this component and this component. This length from Pythagoras theorem also, you know, that can be good. We can reach this position only when, if we move from this and this, then we'll reach there. So we can say that this vector, this blue vector is made up of this vector and this vector. So in other words, you can represent that vector as combination of this vector and another vector which is going in this way. And these two vectors are exactly equal to this vector which is in blue line there. So if we can know this one and this one, it will be easy because we have broken down everything into x and y components, or in this direction or in this, or left, or we can say horizontal or vertical directions. Only two directions will be there, and then every vector we can break down into just two directions, or for that case three direction in z direction also. But here we are taking example of only two directions, x and y. So if we can break any vector into two directions and add them up, and their adding up them up will become easier, as we have seen that if there were only one direction here in this case, then we could add them up very easily. Now we see that here only two directions, and as we know that vertical and horizontal components are independent. Vertical, horizontal and z component, the three components are very independent of each other. They do not affect each other. This has nothing to do with this vector. This y component has nothing to do with z component. These two components are independent of each other. Okay, these components are independent of each other, and so if there are, but you see here, what we call this component, this vector is not independent because it is made up of two things, the x and the y. If we consider this as our convention, then this vector is made up of two things, x and y. It is not independent. You have to go this way and this way, then only you can make this vector, or this vector is made of these two components. It is not independent. But this, if x and y is your sign convention, then this any vector in x direction or in y direction are independent. They do not depend on anything else. So our goal is to break every vector into independent components of x, y and z, and then we can add all x components, all y components and all z components. Here what I'm doing is I have taken a vector. Now first of all, let's see what we mean by component of deeply. Suppose this is a vector whose magnitude is 5 Newton. Whose magnitude is 5 Newton. This vector can be broken down into two components. This and this. So what I mean by component is that if you apply and this component by Pythagoras theorem from trigonometry, you can find out that this will be 4 and this will be 5, 3. So what I mean by component is that if you apply, there is a stone, and if you apply a force of 5 Newton here, 5 Newton in this direction, in this red direction, the direction which arrow is pointing, then it will have same effect. It will have same effect on the stone as these two forces will do. This forces will do. What I mean by this is that if I have a stone here, green color stone, same mass, same everything, and if I apply a force of 4 Newton in x direction and 3 Newton in y direction, then the stone will move in what direction? This direction, this dotted line direction, this dotted direction, or we can say this in the same direction we here, in this direction only, in this direction only it will move. This is the meaning of component, that is their components. If you apply these components simultaneously, then the stone will move, the effect will be same. But breaking into components make addition and analysis of vectors easier, and that is why we break those vectors into their components so that we can add them up, or we can do other kind of analysis. Now let's see how we'll add two vectors. Now we are going to see how we add two vectors. Suppose this is a stone or chair or whatever called, and a force is acting in this direction, another force is acting in the same suppose this direction, which is 30°. And from this x-axis we have to choose a system of axis, and this is 30°, and this is 30°, this is also 30°, 30°, 30°, and the magnitude of this forces, and the magnitude of this force is 10 Newton, and it is 8 Newton. And now someone tells you how to add them up. Someone tells you how add them up and show me the resultant of this vector. How will act? Where will in which direction will the stone accelerate? Okay, so in which direction will the stone accelerate is the question. The mass of the stone is 1 kg. You can take it, and you know the question. Now you have to, first of all, what you have to do is you have to break this 10 Newton into its components, that is x and y components. So from trigonometry, you know, if the magnitude of this is 10 and it is 30°, so by trigonometry you can find out the direction of this length of this side and this side, and these two sides will be representing the what we call magnitude of the components. So the y component for this 10 Newton, if this is 30°, is 10 sine, from trigonometry you can get it 10 cosec. This is sine 30, 10 sine 30, sine 30, which is 10 sine 30 is nothing but 10 sine 30 is nothing but what we call 5 Newton. So y component will become 5 Newton, and in similarly this component, this x component will become cos 30, cos 10 30, cos 30, sorry, 10 cos 30, which is will give you 5 root 3. Okay, 5 root 3. So we see that this upper vector, the red vector, was 10 Newton, and it has we have broken down it into its components, or we can say it can be written down, this red component vector, this red vector can be written down in form of two vectors. One vector is in 5 root 3 and 5 Newton and 5 Newton. If these two will be same, if we apply these two vectors, this perpendicular and horizontal, vertical and horizontal forces on the stone, then it will also have same effect as this 10 Newton will do. So we'll use these two components. In the same way, you can break down this down one, this vector, which is also acting in the direction, in this same way. Downward it is acting how much? If you find this is 30°, if this is 30°, if this is 30°, then you can find out that this vertical component and this horizontal components, this is vertical and this is horizontal, this will come out to, if this is 8, if this is 8, so this will be from trigonometry, this will be cos 8 cos 30, no? So 8 cos 30 will be 4 root 3, 4 root 3, and this perpendicular side will be, this vertical component will be minus, because you have to, as you have chosen this as x y z, you have to maintain the sign convention also. It is downward in direction, so you can say this is what we call minus 4. Minus 4, how? This is, how minus 4? This is 8, this is 30 degree. From trigonometry it is 8 sine 30. 8 sine 30 is what we call 4, minus 4. So you can see now, you see that this stone is being acted by 4 forces. There are 2 forces in vertical direction and 2 forces in horizontal direction. The horizontal ones are 5 root 3, this 5 root 3 and 4 root 3 in the same direction. So we'll add them up. This whole horizontal components, this 4 root 3 and 5 root 3, which will give you 9 root 3 in x direction, 9 root 3, and this is minus 4 in this direction, 4 in this direction, and what we call this 5 in up direction. So as you know that if they are in the same direction, opposite direction, then they will cancel out, and overall result will be 1. So actually, what is the force acting on the body is actually 5 9 root 3 in this direction, 9 root 3 in this direction, and 1 Newton in this direction, 1 Newton in this direction. So the result of these 2 forces will be what? Result of these 2 forces will be, if this is 1 and we want to add them, then the result will be thus diagonal, or we can say if we add them up, we'll get 1 square. So you can find out the resultant from the Pythagoras theorem. 1 square plus 9 root 3 whole square under root, this all will give you the resultant of this force. And direction also you have find out what will be the resultant of the direction. This is the result, this will be the resultant. How this will be the resultant? You can find out the theta also. Tan theta, if this is theta, then tan theta will be 1 by 9 root 3, and from trigonometric inverse also you can find out the angle with which it is acting. So this is the direction, this tan theta, what we call tan theta. If we take this is tan theta will be equal to 1 by 9 root 3, and from calculator you can find out this angle, which will approximately come out to be, you can find out, which will be very small in size. Tan theta is 1 by 9 root 3. So theta, what is the theta? From calculator, using tan inverse you can find out. So you know this magnitude and also the direction. In this way we add vectors, and if there are 3 vectors, 4 vectors, 5 vectors, we do the same thing. We break them into x, y, z components. Generally x, y components will be given, and then you add their x and y component and find the resultant.